Here we begin our journey with the second half of our mold chapter, working out practice test A, objectives 7 through 12. Tools that I have out, and I'll invite you to have the same. The mole map, won't leave home without it. Periodic table, I don't have mine memorized. I need it, along with a calculator. So the tools that we'll need as we progress through our second half, practice test A, part 2. The first objective, which is the 7th one of our chapter, asks us to convert amongst measurements of mass, volume, and the number of particles. These are two-step mole conversions. What we're looking at is being able to convert from one unit of measurement to the other. Perhaps we're given a particle and we want to know how much it weighs. Perhaps we're given a mass and we'd like to know its volume. We don't have direct pathways between the three ways that we measure matter, but there are journeys to have going into the mole and then heading back out. Divide to head in, multiply to head out. No direct path, but I do see a way to get there. In our first problem, we're to calculate the number of molecules of 60 grams of water. Figure out where we're starting on the mole map and find where we want to go, the given and the want. We're given grams, we want molecules. Given a gram, we have to use molar mass to head in and Avogadro to head out. Given a mass, we'll need to find the formula weight or the molar mass in our first step. So as usual, please begin by writing the number, 60, the label, grams of water. Hi. Oh, alrighty. I'm just talking to a microphone. We have 60 grams of water. In my first conversion, I use molar mass. See you, Charles. We have 1 mole of H2O. 2 H's added to an O gives us the molar mass of 18. So step 1 cancels out the gram and brings us to the mole. Keep in mind where the journey has taken us so far. We've moved from the scale into the mole, and now I want to go out to the particles. When I head out, I see Avogadro. We're not allowed to put particles. We have to identify what kind of particles they are. Remember our word bank down here. Are they atoms, molecules, or formula units? Water is a compound. It's bigger than an atom. It's a compound, so those come in 2 varieties, a molecule or a formula unit. H's and O's are both non-metals grouped together, so the correct vocabulary is a molecule. We'll use Avogadro's number of molecules of water. So 6.02 times 10 to the 23rd molecules of H2O in every 1 mole of H2O. Number, unit, label, every step, every time. Let's hit together and find how many molecules in 60 grams. We hit 60 divided by the molar mass of 18. Multiply by Avogadro, 6.02 E23. And we get exactly 2.0, looked way to the end of your screen, times 10 to the 24th. The unit is a molecule, and the label, water. 2 times 10 to the 24th molecules of water. Reading for our second problem. We're asked to calculate the volume in liters of this many atoms of helium gas at STP. Calculating a volume given atoms. Here's what we're given, and here's where we want to go. This many atoms will need to divide by Avogadro to head into the mole, head north to the volume to end with a liter. Let's begin by writing our number, 2.95 times 10 to the 22. The label here, atoms of helium. Helium is an element. Elements' building blocks are atoms. We said that first conversion to bring us into the mole from the individual atoms is to divide by Avogadro. The particles term appropriately labeled atoms, the building blocks of elements. There are an Avogadro's number of atoms of helium in every 1 mole of helium. Step 1 cancels the atoms. We're in the heartland of our mole map, the mole unit. To head north to volume from the mole, we see the arrow bringing us up. We use the molar volume value of 22.4 liters. There are 22.4 liters of helium in every 1 mole of helium. Step 1 cancels atoms, step 2 cancels moles, and now we've landed at the volume of helium. Please hit with me. 2.95 E22 divide by Avogadro 6.02 E23 and multiply by our molar volume of 22.4. We get a value of around 1.1 liters of helium. Let's read number 3. Calculate the mass of 230 liters of argon gas at STP, standard temperature and pressure. We're starting up north with the volume. We're at the balloon. We'd like to go down to the scale, the grams. Starting at the liters, we're going to head into the mole using molar volume and head out to the scale using molar mass. Divide to head in, multiply to head out. 230 liters of argon, number, unit, label. Our first conversion is going to cancel the liters and bring us into the mole. We know that 1 mole of argon at STP would be exactly 22.4 liters big, molar volume. So in step 1, our volume unit used 22.4. Now we're standing in the heartland of the mole map. We'd like to know how much it weighs. To move from the mole to the mass, we need something called the molar mass. Sometimes I call it the formula weight. So with the help of our periodic table, we find argon, its molar mass of 39.948. I'll call that 40 grams. 40 grams of argon is the mass of 1 mole of argon. Divide to head into the mole, multiply to head out. So let's hit together, please. 230 divided by the molar volume, 22.4, multiplied by molar mass of 40. And we get 410.7 grams of argon. And one more. Now I just want you to notice something. So far, our journey has had 3 points apiece. Something must be unique. This one is worth 5 points. Kind of giving us a clue. This might have a little bit extra work involved. Let's take a read through. Determine the number of hydrogen atoms in 45 grams of sulfuric acid. Given a mass, we want to know the number of hydrogens. We better first go to work with some nomenclature skills and turn sulfuric acid into a formula. Acids are telling me they always start with H. Hydrogen ion carry a +1. The acid rules say that if I'm ending with ic, the ic ending, the original polyatomic ion must have been 8.